having invited me here. Of course, probably you heard Mr. Atul Batra. He was my former student sometime in 1995, I think. I have not seen him, but I only saw him at a distance, but I would like to see him later on. The talk which I'm going to give is a very interesting talk in my opinion, but I think you will see and evaluate yourself as, what do we really need? I will also tell you something about what I heard about NASSCOM. I did not know much about NASSCOM, although I've been in States for 45 years. I knew the contributions Indians have made in information technology, both in San Francisco, in South Florida, everywhere around the country, has been enormous and has put, Bangalore and other Indian companies on map. So I got to know a little bit about NASSCOM through Narayan Murthy sometime in 1990. All that he was trying to tell me how this organization is coming. And again, I'm really an opportunity here to come and say a few words on this. Okay, what is going on now? Okay, so I know that the time is too short. I've already spent a minute there. There are four important things that I want to talk about it. First, give a little bit of so we are right now in the fourth industrial revolution. I'll tell you a little more about it. The software revolution. Then leveraging AI technology for software solutions. And then, of course, the future, innovation in research, education, and industry workforce development. And I think that is the order that I would like to go. So let us say we had to be very clear in our mind. I know that sometimes if I'm a little bit too harsh, we can be doing all the things what we've been doing. And I think the speaker in the morning also, Mr. Seth, explained those things don't work anymore. Because I saw in the newspaper today, IT workforce hiring has been reduced. Why? There's not a lot of money on the same things what we are doing. So what is very critical here, we must adapt to changes. What can we do? How can we understand? People talk very loosely. I'm a professor. I am also an entrepreneur, but they use the word artificial intelligence, machine learning so loosely, but that's not it. We have to train our students. We are good. We are analytically very, very good. So, but we are sometimes slow to react. Humans I'm talking. And so the game changer here at this point is to adapt and learn. And this kind of game changer will certainly win. And this is very critical for all the software industries, whether you talk about Infosys, Wipro, and I know everything because I did have some communications even with Vishal some time back, how he was trying to introduce the idea of AI and machine learning, in Infosys several years back, and I think it's going on. But it is very critical for every company, small, big, and there are lots of opportunities too. So I call this as fourth revolution. So if you look at 1784, we have the mechanical production, then mass production and electrical engineering. So let's go into the fourth production. We are in this revolution, starting from 2000, people have been thinking, in all of these important areas, what I call as thinking software. I'll explain to you what is thinking software in a couple of minutes. That is important. So if you look at the computer science, okay, and data science. So data science is very important. We are collecting large amounts of data, okay, all different types of data. So to me, there are two different types of data. One is unstructured data, and the other one is unlabeled data. So you have all of those data. So what can you make out of this data? So there are some techniques, and we have used in some of our own applications, and I'll tell you, and all of these applications that you have seen here, or I have listed, these things, the artificial intelligence and machine learning play a very significant role. Now, machine learning and signal processing, is important in cyber physical systems. We already saw that in our previous thing, like if suppose there is some type of hacking which always happens in the United States, How do you sort of avoid it? Manufacturing control, intelligent manufacturing is very important nowadays. How do you sort of use and develop precise VLSI designs? And communications and support for Internet of Things, which is very important. And of course, what is more important is human automation interaction. How can we play a significant role on this? And there are some other related areas too. Now, you look into these applications. I'm not going to go into that, but there is one thing, the Florida went through a series of, hurricanes. Irma was the worst one. Now, we need to be able to sort of understand, and we do have some technology to predict when it lands and what it does, but what does it do to all the community impact? And so we do have developed an AI-based software in terms of the insurance industries, how they can support all of these people who have gone through, depending on. So all that you need to do is, you get an estimator and get some things, and then give it to these, or embed that in the system, in the software, then it will sort of give what would be the cost. Of course, disaster response management system is also very important. So, there are other examples that I've given. Agriculture and other places are very critical. So, research and development embedded in companies for new software. It is very critical. So, we can be doing the same deterministic software. I'm sure there are a lot of other companies are doing it. But very interestingly, the stochastic software development is very important. What do I mean by that? The input is very random. I'm not very sure. So the people are talking about machine learning algorithms. That is also good for a finite data set. So what happens if, the stream of data that comes, what do you do? So there are methods. There are methods of learning which we need to incorporate in the software. I'll tell you how. So the solution behind this, we need software which can reason like human beings. And that's what we're really interested in that. Now, hundreds of market. See, if we don't change now, we're going to lose the bus, because United States is spending billions of dollars on health-related matter. And you see that every day there is an AI-based software for detection of cancer, or there is an AI-based software for reading all of the radiology images. But there's always a lot of improvements one can do in many of these AI-based software. So if you look at these health-related applications, we have many, many opportunities, because India, we are really blessed with our intelligence. I think we can adapt very fast and at the same time reach the same benefits what we have been doing that. Now, remember, this is another important thing, the agility. Now, you must understand what the client really needs. Okay, that's very, very important. And then create a meaningful technology. See, when I say technology, technology is all about people. It is not software or hardware. So the user requirements, understanding the clients, and at the same time developing a real-time flexible software is something very, very critical in the design of these thinking software. So this, I've already said a few things. So let's see, what do I mean by machine learning? I also want to give you a little bit of an overview on that. People always say, well, we want to have the software like how a human brain performs. See, our human brain is very, very good, because the kind of neural network model we have, where it connects, different neurons, but when it is computing, it is doing both distributed as well as parallel computing. That's one aspect of it. Now, the other aspect of it is there is a chemical analog also. So it is a very complex process of how we really actually do the calculations or recognition, even for a very small child. If you show a small child 4 or 5 different types of trees, and then if you show a new tree, a mango tree, then he will really synthesize all of the data that he already had and comes up with an intelligent decision, yes, that's a mango tree. So that's what we're really interested in. Now, we have to really look into how we can develop this kind of software knowledge so that AI can make certainly a difference. There are some AI applications that I've seen, but that is very, very elementary. Now, the hardware also needs to change, because it is not just trying to optimize your searching and sorting. The hardware should also be optimized for searching and sorting, because one of the things that is very critical is how you store the data. The structuring the data is very important, because you remember you are dealing with all unrelated and unstructured data. So the next thing is, once you have the organization of the data, how do you sort of retrieve the data? That's important. On real time, remember this. So an example like this I can give you, people were giving all examples, how to drive a car and things like that. I mean, those are very difficult problems. Driving a driverless car or having something like that entirely controlled by software is going to be extremely difficult. I mean, I'm sure maybe in the next couple of years we may have something, because I was involved in many DARPA projects where they wanted to have an autonomous land vehicle to go 25 miles without being monitored or controlled by a driver, in a rugged terrain. Let's say, in San Francisco or down in Los Angeles. So those are very difficult, because the vision and all of those things have to be integrated. So the data has to be very clear, and it should be read, and the thinking software is very clear. Now, if you look at it, is this possible? Yes, because I don't know, if you drive a Mercedes-Benz car today, it's very, I would say it is 3/4 automated, because it can identify a person. I mean, because of course it is all completely sensor driven, and you don't need to use your keys or anything like that. But a very interesting thing is, we want that Benz also to learn the personality of the person who is driving. Why do we need that? Because, if suppose there is, some unwanted person will try to control your car, or he may try to do something, carjacking and so on and so forth. But if we have a car which has learned some of the personalities and driving habits of a driver, it is very good. So there are a lot of some of those things can be done, and again the thinking software comes into picture. And I have seen myself, it is so beautiful. If you are driving, and all of a sudden you see something, an event that takes place right in front of you, it gives an instantaneous signal and gives you enough time to stop the car. So what it does is, in principle, it first collects the data, and then it starts working on coming up with rules to how it can stop the car much ahead of time before the accident. So the architecture that we are thinking, or we have used and we have exploited for many applications, called a synthetic architecture for self-learning. Okay, now I will give you another example of our work which has been sort of used. All of you know sprinkler system. The sprinkler system is sort of designed to have, sprinkled water on the grass or on the golf ground periodically once in 3 or 4 hours. So the question that comes to my mind is, this was a 5 or 6 year old problem we solved, and the basic thing here is, what happens if it is continuously raining? If it is continuously raining, it does not use any intelligence, it is still will be sprinkling water. So what we have done, we attached a thinking software to create a decision-making process, and what it does is it samples the soil and see whether it is wet, dry, or things like that, and the temperature, and then it makes the execution which is integrated on that. And that's how we are synthesizing. That is one simple example. And there are lots of other examples I can give you. So what is that we really need in this kind of software? So interoperability, see, we talk about IBM Watson software, that's very good. It has solved many interesting problems. I am not very sure, of course I can be making statements, But interoperability, like if you change the domain, will that be useful? Or you have to really come up with a new architecture and so on and so forth. So interoperability is one important thing. And how do you sort of take into account more intelligence that is to be embedded in the concept of learning software? So the software, what I am really thinking is what we call as understanding or deep learning. So what is a deep learning? So what all of us are interested is to have a software which can sort of imitate human brain behavior, for specific applications. So if you look at it, it is a subset of different machine learning algorithms. So what it does is, all of these algorithms, what it does in an unsupervised environment, it continuously learns and then labels, okay, this is the data that we need to use, and then whatever the unstructured event. Take the example there in the concept of deep learning. So if you look at it, the object we are talking about is a horse. But you can see, you can look at all the details that we are generating based on the data through the concept of deep learning. Now, so this kind of AI and machine learning techniques will essentially able to produce software which we can compete, with many of the US markets. That is very good. So this is also what we call as self-healing software security. There were some security applications, I think some of them were mentioning. All of those things can be taken because it can be programmed. So what exactly I am talking here is, okay, this is all kind of for the next 5 years. You can see, traumatic disorder, improving clinic. So health-related things takes a very important application on many of these things. So one of the things this thinking software it does is, it is what we call as a back propagation for data hungry. It looks for large amount of data, and then based on our creative program, it is not just a simple program, so it creates, a clever way of organizing and then putting it in the form of an algorithm. I'll give you one more example. What our synthesizable algorithm does is, if you show somebody how to open a knob door, then if you show him a different one, he or she will be able to do easily operate. Because we are able to take all the data and synthesize it in such a way that we are able to get the final software. I think I'm running out of, so diagonized manufacturing machine. There is another thinking software we have developed. If your car is making a different type of a sound, then I'm able to find out exactly by submitting or embedding a software to see what exactly the problem with your, whether it is a lubrication problem or it is a problem with your carburetor and so on and so forth. So, one or zero shot technique requires less data. So one of the things what we normally do is to make sure how we can relevantly extract some of these rules that we develop. So if you look at in early 60s, all of the AI techniques and programming, what we were talking, they were not very flexible, unable to automatically deploy them, and there are different AI systems. But today, the software engineers have different types of abstractions that can be embedded and automatically designed on that. So there is another interesting thing which we have embedded in the software called, the curiosity-driven continuous self-learning. So the software which we've been able to explore and is called, so it is a hierarchical fractal architecture. It transfers learning from one module to the other continuously. And there are 20, 25 people around the world have contributed to this. So we can never learn all of these powers that we have in all of those. So basically, the gaps in the current AI capability is the human interactive input. That's what it is, the problem. So we are continuously able to feed the data to the software where it is able to learn faster and faster. So it is very unique than all the AI systems that has been developed, our system, where there is a continuous learning after some training, and by connecting the dots, measuring the quality of success, And if there is the concept, let's assume there is a mistake one way or the other, it can drift it. And self-correcting, and retroactively it does an iteration of all of these techniques and develops a long-term self-learning. So this kind of synthetic and neuroscience is very important in making decisions, in developing. This is what we call as the thinking software. So if this is basically the sensory input into all of these different lobes as the data flow. So we basically what we have done is simulated the human brain decision-making science and incorporated that in the form of algorithms. So a human student can continuously get more expertise by learning. And so the synthetic, or what we call as transfer learning, to reduce the data requirement. So remember, when you have large amount of data, then the processing time takes place. So one of the things we have by doing what we call as a transfer learning, these are the foundational mathematics embedded into that, and it is being used. So here is an example of an original application, ground truth and output. And then, Phantom of the Opera can use segments of multiple tasks, and it can produce several input layer. It can be separated by domain. That's what I said. One of the important features of our thinking software is it can separate the domain, where facial features, visual cues, gestures, and body movements. Law enforcement applications too. I know I got 3 more minutes. Here is an example we tried. You can see somebody is doing a pickpocket to a colleague of mine. And so how he was able to get all the data from video and audio and facial recognition and able to characterize all of these different domains and able to say that. So how this combination of past experiences, reasoning, and embedded intelligence, essentially using simple rules for complex decision making. So this is basically the creative way of designing all of these algorithms for the matter. Now there are different concepts, layers, top layer, middle layer, and third layer. And this is the flow diagram of how, for example, how the system adapts itself to the new environment and things. And then, of course, the new revolution here is, this is a rapid commercialization applications in multiple domains. That's what we've been able to do that, like industrial applications and NASA terrain recognition we have used. You take the sample images and then try to run through this, and then we are able to get all the data, whatever we want. Then US Department of Agriculture Forestry, you can see very well automatic tree cover estimation, then automatic yield prediction, automatic coloring. You just give the input original image, then automatically the color comes out like that. So there are different varieties of applications, and then of course for the drug design problems. And so the finally is about training, the workforce development. This is important because we are quite smart, but we need to be trained. But I think I heard in the the previous lecture, you can't run like this, trying to learn how to design a web page. It is much more than that, because we have to really make sure the students understand the fundamental knowledge of AI in the concept of learning. So developing novel learning methodologies and the revolution, you can see many of these things. And there are a lot of, workforce development. So the last thing I want to say is, this is not a talk just showing you different examples. If you have some time later on this afternoon, go to Google and look for FIU Tech Station. We have started creating entrepreneurs in the workforce development. Nowadays, nobody needs just writing programs. We want people to come up with innovation. So we have developed, in fact, I was in charge, spent several $1 million. I sort of replicated what Google has in our university. So what is the result of that? Maximum number of patents. Every undergraduate student or a graduate student comes up with a very beautiful idea. Okay, so now, this is the last slide. I think it is up to you to change So change is very much needed. I mean, and I think somebody said, working with the government organization, of course, because all of these startup companies, the big companies, major companies have to change. Some of the major companies have already started changing in this way of AI and machine learning. Well, thank you very much for giving me an opportunity to say a few words. And, you can send me an email, or if you have any questions, if I have time, I can answer that. Yeah, yes, one question. Yeah. Yeah, what is that? Okay, good question. Concept drift is, let's assume, see, the thinking software is creating on the fly many of the rules. Okay, so what happens is, let's assume that I'm going in this direction, then all of a sudden I see that I can't go in this direction, but there is a traffic, so I'm essentially say either you back ride or take a different path. So your concept at that time in creating rules has changed, because these rules have to be created on the fly. See, that's the difficult part of thinking software. I mean, that's what we do that, right? Suppose you know all the things of driving, and all of a sudden you see something relevant or not relevant in front of the car, then instantaneously you stop the car. So how do you do that? Then you say that my concept of going straight is gone, I am taking a different direction, create new rules on the fly. That's essentially going in a different direction, before we started the direction where we want to go. So going in a different application, let's put it that way. Okay? I think if you look at, if you have a chance to look at my Google, we have published many papers, but these are not just theoretical papers. These are implemented papers where there are applications, because, I worked for US Department of Agriculture, Department of Energy. In 1986, when I was a research professor at Oak Ridge National Lab, the director of the lab came and said, Ram, I want you to come up with an intelligent robot to move from point A to point B. I did not know what is intelligent robot at those days. I'm talking in 1986. So now you have seen how much of revolution has taken place. That's why I call it as, this is the fourth revolution, and a lot more changes will take place down the road. Now, the reason is, India, I would like to see to play a very dominant role even in this, direction that everybody is planning to go. In United States, of course, like creating the internships, now the whole game of teaching students are very different. It is not traditional like what we used to do, or what when I was in 1978, 74. It is something very different. I mean, working in an industry is a very important thing, because that internship essentially gives them a lot of experience. And that kind of industrial experience is very much important for every student, whether he graduates from IITs or Institute of Science, it does not matter. Because that kind of experience, coming back and trying to apply for applications on that. Okay, thank you very much. I don't want to take any more time. Yeah.